Talking about the study of Earth surface, environment, or things to do with location, context, skill, or how places shape outcomes. Okay. When you hear spatial, usually has something to do with arrangement or distance, or how things are positioned relative to each other. Okay. Things related to proximity or boundaries or patterns or clustering. Okay. And then finally, there's AI, which is, broadly speaking, machines that learn patterns from data, which is a very, very broad way to describe it. Okay, so generally, AI has to do with systems that find patterns in large data sets and then use those patterns to either make predictions, classifications, answering of questions, etc. Okay, what distinguishes AI is that learning is done from not just from explicit rules, but also from example. Okay, so putting these three together, we have geospatial AI, which is AI applied to spatial and geographic data. Okay, so in this case, these systems, these GeoAI systems, are able to detect patterns that vary across locations, and they're also able to help us reveal why these spatial patterns exist, and not just where the patterns exist. At this point, is there any question? I guess not. Okay. Um, so what we would look at now is, why is geospatial AI important? Why does location matter? Now, this is an example of a particular question being asked in the context of two different places. So we have Greater Accra and then Upper West, and we'll take the question to be, what is the price, okay, of rice per kilogram in these two places? So geospatial AI would basically help us to answer why there's a difference in the price of the same amount of rice in the same country on the same day, but in different locations. Okay, this is just a little use case or explanation of GeoAI. But we'll also look further into some other places where GeoAI is found around us. Okay, so we have in route navigation. So if you've used Google Maps or even Uber, okay, they use real-time location data with AI to be able to identify routes which are maybe the fastest. Okay. And then there's flood risk mapping. So I know that Google has some flood risk systems, which is basically a GeoAI system that's looking at the geographical space and then applying the abilities of AI to help identify places where they have a risk of flooding so that we are able to find solutions before serious floods happen. Okay. And then there's for crop health monitoring. So if we have satellite images, AI is able to help classify things like crop disease, yield predictions, and make yield predictions with the help of this geo data. Okay, there's also for disease outbreak tracking, urban planning, and then the use case that we are looking at today, which is food price monitoring. Okay, so we'll be using the World Food Programme's data for that, and we'll go much deeper into that over the course of this talk. Okay. So the next thing you might find interesting to know is that GeoAI is, as a field, as a name field, is actually relatively recent. Okay, so AI as a concept around the 1950s. Computer vision, where AI was applied for helping machines to actually see and understand what they see, started around the 1960s. Okay. And then NLP around 1980s, deep learning 2012, and GeoAI actually is around 2018. So it's a relatively new field. However, there has been something there before, which is GIS, geographic information systems. The thing that is new is the addition of AI into that. Okay, so you could think of GeoAI as some kind of combination between GIS and machine learning or AI. Okay. And specifically in Ghana, there are some outstanding use cases of GeoAI, such as Farmerline, which is a Ghanaian agri-tech company that uses location data and AI to connect smallholder farmers to inputs to give them insights based on weather data and markets. There's the Ghana Statistical Service that uses spatial analysis to map poverty, census data, and infrastructure gaps at the district level. There's the data we are using today, which is actually from the World Food Program. And this data allows for monitoring of food prices at markets across the country. Okay, to detect supply shocks early, and to feed into regional food security assessments and humanitarian response planning. Okay. And then finally, satellite data on Galamsey. So satellite data analysis is actually able to help in detecting of illegal mining activity and deforestation from the orbits, right? So geospatial AI techniques are actually able to help us identify land use change and to alert enforcement agencies. This is just a little background, and we are going to go straight into what we have today for the project. We'll look at the question we are answering, the plan that we are going to follow, and then a bit of the full picture before we actually go to the code. Before we start, is there any question, anything to clarify? Okay. So the question we are answering today is, where in Ghana is rice most affordable? Okay, and this is a GeoAI question because the answer depends on the location. And it matters because it actually affects real households, how they make decisions about food. Okay. So the steps or the things we are going to do, the first thing we'll do is to get our data. All right. So our data is from the World Food Program. And aside that, we also have geographical data, which is gotten from HMX. We'll look at the website very soon. Okay, so that gives us data on Ghana's boundaries, Ghana's regional and district boundaries. Okay, so the World Food Price data is a CSV file, kind of like an Excel. And then the GeoJSON is a specific kind of data, data type that has the geographical data points in there. Okay, and then the next thing we'll do is to filter out the World Food Prices data set to focus on just rice. So the World Food Prices data set has several different foodstuffs in there. But for simplicity, we'll filter it out for just rice. We'll do some little data cleaning. And then we'll take the latitude and longitude numbers in that data and then map it into points that allow the system we are building to understand the geographical location of those points, right? So that they cease to be just numbers, but they now have like a a location meaning to them. Okay. After that, we would connect our resulting data into a map, and then we would compute some summary metrics of the prices based on region and district. Then we'll plot our map, and then finally we will add the AI parts to it, where we would create a very simple RAG chatbot that answers questions based on what we have created. Okay, based on the map and then the insights from the map. Okay. The next thing we'll look at is the tools that we'll be using. So this is going to be done fully in Python. If you have some foundational knowledge of Python, then you may have already met pandas, which is basically for data analysis and data manipulation. So this is what we use for loading of the CSV files, filtering of the rows, things like that. Matplotlib for plots, NumPy, and request. These are the ones that are more commonly known. And then the ones which are specific to geospatial and then AI, we have GeoPandas and Shapely for working with the geographical data. And then Gradio is how we'll deploy the RAG chatbot that answers questions based on the system we've built. Okay, up to now, is there any question? Are we all following? Okay. The next thing we'll look at is the data that we are using. Okay. As I mentioned earlier, there's the HDX platform. Okay, this platform actually has a whole lot of data across several different countries. I think I would like to show you exactly what the interface looks like. Let me exit the screen here. Okay. So I will be sharing with you the notebooks, the code notebook, which has all the information, especially also the links on where you can get all the data from anyway. But this is how the interface looks like. Okay, so you can go to, if you are looking for data on any particular country, say Ghana, you can come here, go to locations, and then you choose Ghana, and you can already see there are 206 data sets available. So depending on the use case that you might have, you can either search. So for example, I'm looking at food prices. So you can search and then you would see all this data available. Okay. If you are looking for population data, similarly, you can also get that. Okay. Then you can do filters and things like that. I think this is a really useful resource, or a useful source of data. This is not the only source though. You can also go to the Ghana Statistical Service, I believe. They have a website that also has data there. And especially for data on, like, say you want to create another system that is using Ghana's, maybe Ghana's boundaries, the regional boundaries, the district boundaries. You can also find that boundary data here as well. Okay, so everything is really here. GeoJSON. Yeah, so GeoJSON is what gives us the boundary data for what's, I mean, for the GeoAI use case. Anyway, that's just by the way. Is there any question on this so far, on the data and what you can access here? I believe that you can go through it and just have fun with it, find things on your own. Okay, so we'll move on. Sorry, let me find. We're here. Yeah, so there's a wide range of data from food prices to population displacement to health facilities data, administrative boundaries for every country. There's climate, weather, and environmental data, infrastructure access, and road networks. But then if whatever use case you might be thinking about, you don't see here, you can still check the website. Okay, this is just a subset of things that you can actually access from there. Okay. So we decided to filter with rice. Why rice? Rice is a cultural staple. Many people there are so many different things we use rice for: jollof, wachi, uh, rice balls, etc. So I just thought, okay, let's just use rice. Okay. Also, Ghana imports about 65% of its rice. Um, this means that the rice prices are partly set in global commodity markets and are also affected by the exchange rates. Okay. So, for example, a crisis in Southeast Asia can raise prices in Kumasi within months. That tells us that the price of rice tells us something even deeper about the economy or the state of things. Okay. Uh, um, but there's data on cassava and yams and things. They are all in the data set, right? But we just focus on rice. And it's also a clean signal for food security since it is so widely consumed, and it is one of the more consistently consumed foods across the seasons and regions. Okay, at this point, we are going to start with our code. So there's actually more slides ahead, but then the code, the notebook that we have is pretty comprehensive. Okay, there's a lot of explanations in the markdown cells and things like that. So you can actually walk through that even on your own, and I believe that you'll be able to understand it to a large extent. So let me just find that. Okay. So as I said, this is a notebook. It's supposed to be self-contained. So when you have access to it and it's available on my GitHub, you should be able to go through it and understand it even without me walking you through it because there's a lot of explanation in there. Okay. I have all the codes written already. So we'll just understand them and then we'll run them. Okay. Is the font size okay? Should I increase it? Okay.
I think increasing it will be okay. Just,
Sorry.
can you increase
Is
it a
this
bit?
okay?
Increase?
Wow. It's as big as I can get, I think. Is this okay?
Okay, yeah, that's okay. That's okay.
Okay. Maybe let me go through the introduction a little bit. So it explains the different libraries we are using and what they are used for. Um, every data analysis journey starts with two critical steps: getting the right tools and loading the data. So the first thing we'll do is to get the libraries that we are going to use. I already showed you what those libraries are in the slides. We'll look at them again here. Now, when you are running this code for the first time, you might get some error about having the libraries already installed. Okay, so in that case, what I'll do is I'll add, there's this line here, pip install. Okay, let me quietly install it. Geo pandas, max, shippy. Okay, So you could have that there, and then if you have an error about the libraries, you can just check that. So the pandas, as I mentioned earlier, sorry, it's for data analysis and data manipulation. There's GeoPandas for that geographical edge to it. So it allows you to it's basically the same thing, pandas, but then there's an understanding of location points in there. Okay. There's Matplotlib for plotting, Shapely for helping us to convert the longitude and latitude points from numerical into something that pandas or Python can actually understand as a location. Okay, so we can map it to the map, to the Ghanaian map. This is just to suppress some of the warnings that we'll get. And then these are just some configuration code. I mean, it's not necessary really. They're just configuration codes. Yeah, so there's that. And then the next thing is the data sources. Okay, so actually all this code is on GitHub. It's accessible to you and it includes the data. Okay, so if you come here, you should see the data in its raw form. We would process it, so you would see the process form. All of it is here. But then if you still want to download it yourself, I have added the links to do that here. Okay, the data source links are here. But aside that, you can just read in the file. This is an absolute path. You will need to probably clean some part of it if it doesn't run on your computer. But then here we're just loading the data. Okay, so yeah. So let me run this. So I load the world food price data. Okay. Then we have the regional boundaries data. These ones are GeoJSON files, so we load it with GeoPandas. Okay. Using the read file function. So I'm going to run this. And then, okay, we'll inspect it right below. So you can see from here we have 26,667 price records. That's a lot of data. We'll take a closer look at and see what exactly the data has in there. Okay. So before analyzing, we have to look at what the rows represent, what are the columns available, if they're missing values, the data types that we are working with. Okay. So the first one that we'll look at is the world food price data. Okay. So this is how the data looks like. We have the dates column, admin 1, which is basically the regions. Then admin 2 is the districts. Okay. Then we have a markets column, market ID, the longitude and latitude. Okay, so right now these are just numeric values. Okay. Then we have the different categories and then the different commodities. Right. So we'll be filtering according to the commodities here. Then we have the commodity ID, the units, the price flag, price type, the currency that we are looking at, the actual price, and then the USD price. Okay. So each row is representing a particular commodity at a market on a particular day and what the price is. Okay. So the thing that differentiates the columns is the dates. So you can have the same good, same place, same market. And we are looking at how that is changing over time from 2006 all the way to I think 2023. Let me just verify that. So we can do FP. data, state. Okay, so 2023, 15th of July. That's the last date that we have. Okay. So over here, we're just checking the column names and the types. It's important to know the type. Okay. The type of data that we have. Okay, so right now the date column is object. Object means is like a string. Okay, these are all strings. So the first thing we'll need to do is to actually give them the right data types. Okay. At this point, is there any question? Am I moving too fast? Do you follow? Um, so let's consider the key columns that we are looking at for analysis. Okay, we'll look at admin one, which I mentioned is the region. Maybe I should just add that in here. So admin one is the region. Admin two is the district. Okay. Then we have the market, latitude, longitude, the commodity.
I'm not sure that we actually set it. No,
Sorry.
I don't have it in the calendar, no.
Hello? Can you repeat yourself?
Yes. A kind reminder that when we are not presenting, we should please mute our microphones. All right,
Oh.
Chantelle, you may proceed.
Oh, thank you. Okay, so these are the columns I will be looking at. Okay. Everything is here. Then the next thing we'll look at is the administrative boundaries data. Okay. So the geodata frames have all the features of the normal pandas data frames, and they have a special geometry column that contains spatial shapes. Okay. So over here, we're going to just look at what the dimensions of the data is. So there are 16 regions and then 6 columns. So these are what the regions represent. They are there in the shape name. Okay, so I guess what I should probably do is to give us a look at the actual data. So this is what it looks like. We have the shape name. So this is the data that would actually allow us to plot Ghana's map with the region, the regions indicated in there or outlined in there. Okay. So the data set has the region names. It has the shape ID. This is like kind of like a key. All right. Then the group, the type, and then the geometry. So this geometry is responsible for actually giving us the outline of the shapes. We'll see that soon. So this is one of the data that we got from HDX. Okay, this is the regional one. And then there's a similar one for the districts. And the districts are way more. They are 260 in this data set. So a couple of them we have here. So there's Karaga, Gomoa West, Gas Central Municipal, Tano North. Okay. So from the data we have looked at so far, we've been able to see that we have thousands of price records across time. Okay. WFP data. That's shape. Yeah, we have 26,000. So 26,667 price records across time from 2006 all the way to 2023. Okay. There are multiple commodities in there. Oh, I even wanted us to look at the different commodities that are available. So let me do that quickly. Oh, sorry. So commodity. So we have, maize, yam. So even the rice, it is categorized under local, imported, and paddy. Okay. Then we have cassava, millet, sorghum, and there's a lot of data on all of them as well. Tomatoes, peppers, fish. Okay. This is just for your information. There's a lot of data on the different foodstuffs. Okay. Then we also have the boundaries data, which I've shown you. So the GeoPandas allows for that final column there where there are the boundaries which would be used to actually plot out those regions within the Ghana map. Okay. So there's the admin one for the regions, two for the districts. Each has polygon geometries that define their shapes. Okay. And then the CRS, coordinate reference system, that tells us how to interpret the coordinates. Okay. Now, so you'll notice that now we have the price data, and then you realize that we had the longitude and latitude column, right? So it means that for each price, we can actually find that point on the Ghana map where the price is for. And so you notice that in the plan that we did, there was a point where we said we are doing mapping of points to the regions. So it means that we have to find a way to locate each of those latitude longitude points within the regional boundaries that we have from our GeoJSON data. Okay. And we'll do that next. These are reflection questions. You can go through them as you're going through the notebook. So the next thing we'll do is to filter and clean the data. Before I continue, are there any questions? Are we all following? Am I moving too fast? Okay. Thank you. So we are going to filter and clean the data. The first thing we'll do is to narrow all the commodities, narrow the data from all commodities to just rice. And then we'll look to see if there's any cleaning that the data needs. We'll clean any messy numerical data. And then we'll prepare our data for the spatial operations. So this is just finding the commodity column. Okay, so we have rice, local, imported, and we also saw the paddy. Okay, so we filter for the rice here, and then that gives us 4,000 and 183 records, which is about 15% of the data. So, okay, let's do this. So we have WFP data. Let's see. We have and the last one was, I think, rice paddy. Rice. Okay, then we'll subset yeah. So that gives us the data for just rice. Okay. Rice local. What's it? Let me check to be sure that this one has FP data, rice. Rice dot commodity. Okay. Okay, yes, I didn't get the paddy right. Oh, space. Okay, great. So we have that. Then the next thing we'll do is to first of all identify and then clean any inconsistencies, okay, or things that are not right with the data. So the first thing is, remember when we checked the data types at the top, we noticed that all the columns were text or were strings, okay, but we need the numerical columns to be numeric. So we'll convert the price, latitude, and longitude to numeric columns. Okay. And then we'll also remove the first row, because the first row had, okay, let's see the data again. So WFP data. So okay. The first row has this thing here. Okay, so we're going to remove this, and then we'll convert longitude, latitude, and then price, okay, to numeric. This is for removing the first column. Do that. We have this. So the clean data should now be called price data. Let's check that. Okay. So the first thing we notice is that that one is not there anymore. And then if we do price data info, you can see that these columns have now been changed to floats, which are basically numeric data type. Okay, and then the price. We don't touch USD price because we are not focusing on that for this analysis. Okay. Then the next thing we'll do is to convert from tabular data into spatial data. Okay. So in this case, it involves using the Shapely to transform our longitude and latitude from numbers into a spatial object that can actually be used to locate where it is on the map. Okay. So something like this, something like that. As I said, the explanation is really just to help you to understand it better. So you can look at that. Okay, so over here we are taking the longitude column and the latitude column. Okay, we zip them together so they become a tuple, and then we convert them into the point object here. Okay, so when we create geometry, let me print this out. Geometry. This is what we get. We get a list of the corresponding point objects for all the longitude, latitude pairs across the data. Okay. And then we recreate a geodata frame now with the help of the GeoPandas data, GeoPandas library, sorry, that has our same data and then has the geometry column, okay, which we have now assigned to what we just created here. Okay. So let's do this. Let me show you how the data now looks like after doing this conversion. So let's do this head 3. Let's see. Okay. So you see everything here is what we already know from the data, and then there's another column here, which is just the points object for the long tail that we have here. Okay. Then the next thing we'll do is to put that into the map. Okay, so we want to see how that looks like on the map. So the first thing we'll do is to set the CRS. This is to allow us to get the Ghana map. Okay. So we set the coordinate reference system. So depending on how you set it, it just controls how the Ghana map will look like. Okay. So this is the best one to use to get it looking the way it's supposed to look, because the global data is a sphere. Okay, so the coordinate reference system that you choose kind of aligns it based on the country that you want to focus on. Okay, then yeah, we set that for our administrative boundaries here. Okay, and then the reason why we are doing this is so that we can visualize the data. Okay, so this is what we have here. The red points here are representing the different markets. So the points that we converted from longitude latitude were to allow us to make this mapping onto the Ghana map now. Okay. Are we all okay up to this point? All right, great. So this is how the map looks like for the different markets that we have. Now you observe that there are some regions that have no markets in there at all. Okay, this one has one here. This doesn't have any. This doesn't have. This also doesn't have. Okay, that shows us the gap that exists in the data. Okay, so even the World Food Program data set doesn't have data on all parts of the country. Okay. Well, this is only for rice as well, so maybe it's possible that for the other commodities there might be data points in those parts. So okay, so the first thing we're going to do is to perform a regional analysis. Now, to do this, we'll need to aggregate the prices over the regions. Okay, so we'll do regional averages. Now, given that the data is skewed, instead of using average, we'll use the median. Okay. Yeah, so it's robust outliers. So here we are performing a spatial join that helps us to map the different market points to the specific regions that we have. Okay. So we have this code here that uses the sjoin, spatial join function from the GeoPandas library to perform a spatial join, basically allowing us to map the geometry points that we have in our rice geodata set to what we have in the Ghana admins data. Okay, so that's to help us to basically align the two data points, the two data sets. Okay, so that's the main thing that is being done here. Okay, the spatial join. Okay, so after that, we should see how many markets were able to easily or perfectly be placed in a particular region. Okay, the breakdown of that is what we see here. Okay, then after doing that mapping, the next thing we will do is to do the actual averages over the different regions. But before I do that, let me show you how this data looks like. So we have this is the rice region data that we know, and then there's now the Ghana admins data. Okay, so they have been merged with an inner join. Okay, so that for each row we now have the specific administrative region, where that is being mapped onto. Okay, then we aggregate over the regions. So we do this by just grouping by the price column over the regions, and then we calculate different summary statistics. But what we really use for our plots will be the median. Okay. So, I mean, when we do this here, it gives us just the price. So we need to bring it back into the geometry data. So that at the end, what we have will be the aggregates over the different regions. Okay, so this is how it looks like. So we have the different regions, the median price, the number of markets in there. Okay. Now I realize that for those regions that we saw didn't have any market, any data points for rice, we said that we still have null values for them, and that's okay. The next thing we'll do is to create the choropleth map, which is basically is a Ghana map with heat maps on the different regions, showing the magnitude of the median prices. Okay. Before I continue, though, is there any question? Are we all following? So with the map that we are creating here, the darker colors would mean that in those regions, there are higher rice prices. Okay, and then the lighter colors will represent lower values. And then the white or gray area are just those places where there's no data available. So this is from the matplotlib. Going to create the map, we just need to get our regional map data, which is what we have. Yeah, okay, this is not even the full data anyway. Let's look at the full data. So we have regional map head. Yeah, so it has everything, including the geometries. Okay. So you do regional map.plot, and then you indicate the column that you want to have the colors being according to. Okay. Then the axis is defined by this one here. As what like you, this is if you want a legend, and then over here we have set the colors, the color map that we want to use. Okay, all these things. Then this code here is just for the region labels. Okay, so that we're able to see what is the actual median price value over the different regions. Okay, so this is what we have. Maybe I should zoom out a bit so that it's easier to see the plots. Okay, so over here we can see that in this region here, oh, that's the northeast. So in the northeast region, that's where there's the highest median price of rice. Now, notice that in the data we had it over the dates, right? But over here we're not looking at dates. We've kind of aggregated it over all the dates. Okay, so this is like just over all time from 2006 to 2023. They have the highest median rice price. Okay, and then the lowest is here. Oh yeah. What's that region? Okay, so the rest is here. And then in these ones here, we don't have any data available for them. So this is the very first major plots that we've done. The next one we will do is similarly, but then for the district. So in that case, everything we did for the admin regions 1, you basically just rinse and repeat for district data. Okay, we have that here as well. So we will do, so given that we have our rice geo data, now we do the spatial join, but instead of doing it such that it maps the points to regions. We are doing it such that it maps the points to districts. Okay, so let's have a little look at what that looks like after we do the spatial.
Can you
Yes.
zoom out a little bit? It's very
Zoom in.
difficult to see. Yeah, yeah,
Okay.
yeah. Zoom.
All right. Is it better?
Just a little. Okay, it's fine.
Okay.
It's fine.
Okay.
Thank you.
All right. Welcome. So let's do. Oh. Let's try this. Let me see. Let's head to. Okay. So similar thing here, and at the end we see that we've merged it with the admin2 data. Okay. So what we have here are corresponding to different districts instead of regions. It's basically the same thing, just with the other data, the admin2 data. Okay. So now when we see we're still focusing on the medians. Okay. Let me see. Of this median price per district, yeah. Now the thing is that with the different districts now, you realize that okay, maybe I should go all the way back. Let's go back to the plot we did that showed where our points are. Okay, I should zoom out to look for this thing. Okay, let me see. I'm zooming out so you can see. Whereas that for the points we have, this is for rice data anyway. Maybe if we had added some other commodities, we'll see more markets. There are whole regions that have no points in them, and the districts are actually even much smaller. So presumably, we would have fewer districts that actually have data. I'm just showing you this because from the observation we have down here, let me zoom back in. Realize that out of the 260 districts in Ghana, we have just 37 that actually have some data. And it's understandable because the data points for the rice are so sparse in the map, right? So and then the other thing is that even among the districts, not all of them have so many different observations. So what we first do is to filter so that we include only districts with at least 2 observations. So you can even make it just 1 observation. Um, just to make sure that our median estimates are more robust. Okay. So when we do that, this is what we have. These are the districts we have left. There are 33. And then we would create a map similarly to how we did before. Okay, so when we create a map, this is what we have. Okay, similar code or maybe even the same code. Perhaps over here we just changed the color map to red, yellow, green. But then here you can see these are the boundaries for the different districts, and we have just a handful of them that actually have data in them. Now, what I want to do now is let's go back and maybe change this to 1 to see if it really adds more to the data. Okay, so that adds about 4 different districts in there. And then Yeah, we have just a couple more. Let me zoom out again. Because there's a whole lot of districts with no data at all. If you really want to play with it, you can go back and then maybe consider some other additional foods. Okay. I think maize was the one that had the most. So maybe if we did maize, we would have something even more comprehensive. There'll be more district data. Anyway, but this is what we have so far. And I mean, it doesn't mean that the other districts they're not eating rice or anything. It just means the data is not available. Okay, so that just shows us that there are actually data gaps that exist. Okay, so we are basically done with the geospatial side of things. Okay, we now have a system that is able to identify the different regions, the different districts, and what are the price levels in there. Now we are coming to the AI part, where we are going to create a little chatbot that we're able to query on rice prices across the country based on the data we have, and then get responses, okay, based on that. Now to do this, there's two ways to do it. As I mentioned, when we're talking about AI, we're talking about pattern, uh, we're talking about things that are able to predict or get information from patterns. So there are two ways to do it. There's using an LLM. So if you have an LLM's API key, or if you use some of the models that exist on Hugging Face, you can actually run this for free, but then it's um usually takes a lot of space on your computer, and usually they run really slow as well for the good models anyway. So what I'm using here in this notebook is an OpenAI API key. Okay, this is something you need to pay for. So if you pull my code, you will not have access to my API key. If you wanted to use it, you would have to get an API key. Otherwise, you can actually download local models which are free. Okay, from Hugging Face. Maybe I should just quickly show you that before we move on so that you see where you can find that. Just a second. Okay, so here. So you would come to just go to Hugging Face. Hugging Face. Cool. Okay. Brings you here. I think you need to create an account. Yeah, you should create an account with Hugging Face. And then you can come to models. Then you go to text generation. Okay. So these are all text generation models that you could use. Okay. So let's just click on one random one. And there's usually a quick setup guide that would guide you on how to download a model and even how to run it or use it. Okay. There's chat template and everything. So you can use a locally hosted model. As I mentioned, the only thing with that is probably space and then how fast you get responses from the model. Okay. So maybe I can add a link to Hugging Face in there so that you can run that part of the code. Otherwise, there's also something called grok.com. Yeah, this allows you to run. It allows you to use an API key for free. Okay, but it's limited, obviously, and Yeah, you can access actually the big models, the good models, but then there's a limitation on that, so you need to create an account with them. It's just by the way. In my code here, I'll be able to run it with the OpenAI's API because I have an API key. Okay, so what you'll need to do is, oh, before I continue, is there any question? Are we all following? Am I moving too fast? Okay, yeah, okay, that's great. Well, let me zoom in again. So we are going to build an LLM powered question answering function. Okay. So in this case, what it will allow us to do is to create something like a chatbot that can receive a person's question on rice price in Ghana, okay, in any region of Ghana, any district. And then it would select the right data to answer the question, and then we'll provide an answer for you based on the data that we have. Okay. And the OpenAI's API key, or where the LLM comes in, is in interpreting the question. And then after getting the answer, providing that answer back to the person in a natural language format. Okay. So the computation will be done by Python, and then the LLM is just like the middleman who's interpreting and providing answers. Okay. So to do this, you need to import the OpenAI's library. Okay. And then you need to initialize it here. I already have my API key and my environment, so I mean it would just pick that up. Then we build the context. So the context is kind of like the system prompt. Or it contributes to the system prompt that you give to the chatbot. And that's what actually ensures that the chatbot is answering questions based on the data that you have and not from its own knowledge. Because over here, I'm using OpenAI's key, which means that it's basically being powered by ChatGPT. And all these questions you might want to ask it, ChatGPT itself will have answers for you, right? But if I want to make sure that the answers don't come from just ChatGPT's knowledge, but from the data I'm using, then I need to create a context that ensures that. Okay. So in the context, okay, let's see. Yeah. It starts with okay, so this is just a summary of the data that the LLM will use. Okay. So first of all, we have the regional prices converted into a string. So let's look at how this will actually look like to ChatGPT. So let's just come here, and then okay. So these are the columns. No, not the columns. This is an example data. Okay. So we have the column. This is the whole data in a string. Okay. And then so this for the regional summary. Then we have the district summary. We have data for the top districts. Okay. And then the last 10 districts as well. So top 10, last 10. Because I think there were 37 districts we had data on. Okay, so we just filter for the top and then the least. And then we now create the context. So the context is the system prompt that ChatGPT will always be receiving and using to answer questions. So in this case, we have UI GeoAI assistant that answers questions from rice prices in Ghana, you have access to real food price data from the World Food Program. All prices are in Ghana cedis per 50 kg bag, unless stated otherwise. And then regional rice prices summary. Then we give it that data. Okay, then districts rice prices. Then we give it things like total districts sufficient data. This case is now 1, but anyway. Then total districts in Ghana, total regions. Then we give it the most expensive districts, least expensive. We give it statistics and things like that. Then we add rules. The rules are important because they make sure that the chatbot follows exactly what you want it to do. Okay, without the rules, they might just be doing crazy things. So we have only use numbers from the data provided above. Never estimate or invent values. Because in as much as you are calling the LLM, it still has its knowledge of patterns in text that we'll always want to use to answer. So the rules are what the guide rules that make sure that it answers based on the data that you are giving it. Okay. If the data doesn't contain information to answer the question, say so. Keep the answers concise but informative. When mentioning prices, always include the units. And then use Markdown for formatting for readability. Okay, so we add the rules, and then that's it. So that's what gives the context. Okay. Then for the actual answering of the questions, it calls on that context right over here. So the system prompt is what takes in that context, right? And then this code here is just what is actually going to be calling to ChatGPT with whatever question that the user would give, always taking in the system prompt, and then the answers will be generated as a response. So the output of this function here will be the answer that ChatGPT gives. We give it a response. Okay, and then we return the response. Okay, so this is what we have. So we are testing it now. If you give your question to the answer question function, which region has the cheapest rice? The answer should come as test answer. And over here, the answer is the region with the cheapest rice is Volta region, which has a median price of 55.81 Ghana cedis per 50 kg bag. Okay, so now we basically have the brain of the chatbot. The next thing we need to do is to insert that into a chatbot interface. Now, Gradio allows us to do that very simply. Gradio is a Python library that basically allows you to easily deploy a function. Okay, so even you can create a simple addition function and then deploy it as something with a nice UI with help of Gradio. So, I mean, this is basically the answer question function, but then we've just, made it such that it would catch errors gracefully instead of causing the thing to fail. So with the Gradio interface, what you need to give it is the function that you want to use. Okay, the function that is going to be taking in the inputs from the chatbot and then going to be bringing out the output. Okay. Then in the input here, what you are defining is, first of all, what kind of input you're expecting. So gr.textbox tells Gradio that you're expecting text as your input. Okay. The lines tells it how to display the input box. So I'll actually show you how it looks like, but I'll need to move the code. I'm just showing the code first. Then the placeholder text is what defines what you see in the input box. So you will see that soon, you'll know what that means. The output here is defining what the output type looks like. The title here would be what is on the top of the interface. And then there'll be the description. And then there'll be some examples that you can use. Okay. So demo.launch share equals false. Share equals false basically means that it's not something that you want others to be able to use. But if I do share equals true, Yesterday this wasn't working. I hope it works today. Basically, it should allow me to get a link that I can actually share with anyone, anywhere, to be able to access my function as well. Okay, so same problem. But we can just, okay, so we have it here. So this is what Gradio allows us to do, right? So you can basically ask your question here. Let me ask one question that's already here. Which region has the lowest median price? Then you submit, and then your answer comes there. Can you see? Yeah. Then let's say we ask how many regions have data. So there are 12 regions in Ghana with data on the rice prices. What patterns do you see? Mhm. And these are all based on the data that we have used, right? So that's about it. Further things that you could do, you could. So I have, okay, let me see. Yeah, so this is about it. The further things you could do could be to incorporate the dates into the data and then see what are the patterns over the different regions, districts, as the years are going by. Okay, number one, you could also decide to incorporate population data and see if there's a correlation between population and then the price of some of the goods and things like that. Okay, but this is really about it. Is there any question as we close?
Okay, so I believe Chantelle is done with the presentation. If you have questions, let's feel free to ask. Okay,
So,
let me start with this. Chantelle, did we have, I might have missed that portion during your presentation, but when you were cleaning the data, did we find any columns without data?
no, there were no columns without data.
Columns without data, okay. That's fine. All right, do we have any more questions? All right, Esmond, you may go ahead with your question.
Okay, this is not a question per se, but I was wondering if you could share the link to your this repository on GitHub.
Yes.
Yeah, I think the
Sure.
yeah no I think we'll share the video, the recording and everything on our YouTube channel. So the this day will be there. The links to the GitHub repos and everything will be there. Right? Yes.
This is the link. I mean, this. But then, as you said, you have access to it. I'm trying to look for the chat to put it in, but I.
Okay, Astrite. I don't know if I pronounced it right. Maybe Melvin. Melvin, you may go ahead. Melvin, we can't hear you. If you have issues with your microphone, you can as well
Can you hear
type
me?
the question. Yes, loud and clear now.
Okay, sorry. I say thank you, Chantelle, for the presentation. I have just two questions. The first question, I was not sorry first, I was not really on time for the presentation. My first question is about the data set. Is it like a real case study or maybe just random data set you select to for application? And the second one is for in the real maybe case setup scenario where basically the tool you want to develop is for maybe I don't know, farmer or other thing. What is the main thing we need to add in the current tools you show with us?
Okay, so first of all, the data is actually a real world data. I got it from here. So I will actually share the slides and you'll be able to see the data source. Okay, so it's actually real world data. And to be able to do such an analysis where you are mapping some particular real world indicator to the different geographical regions or areas in a particular place, you would need the CSV that has those data points in the particular regions or locations, and then you will need to have your regional boundary data. Okay, so maybe let me go back to the slides and show you the roadmap we have here. So with the data, you will need to have your indicator data and then your boundary files. So the boundary files will allow you to get your plots of the country with the regions or districts. And this is what gives you the heat map colors that go into the different regions. Have I answered your question?
Yes, it's okay, thank you.
All right, any more questions? Or you can use the chat and type your question in there if you have problems with your microphone. Okay, so I think that there are no more questions, and so I would wrap up for this session. This session has been really insightful, particularly the aspects where Chantelle pointed out some where you visualize the data and pointed out areas where there are data gaps. I think those are critical areas for exploration. And so that is really amazing. Apart from that, you also pointed us out to some really good resources, for instance, where you got the data from. And the most interesting thing about that resource is that it doesn't only contain Ghanaian data. Its data is global data that is contained over there. And so I think that that is also one good thing that I have learned in this workshop. And so we would want to say thank you so much, Chantelle, for making time and spending time with us today, enlightening us in such a great deal. We really appreciate your time. We really appreciate everything that you've done for us today. And we will also want to say thank you to all participants for making time and contributing to this workshop. So we would want to say thank you too. And I will also want to repeat that we would put the recordings for this workshop on our website and also on YouTube. I have put the links to our websites, our YouTube, our LinkedIn in the chat. And so feel free to pick the links, connect with us, and let's interact more. Thank you, everyone, and we'll see you in the next seminar next month. Thank you.
Thank you.